Okay, so let's take a look at another proof, very similar to the injective proof. We're going to now show that it's true also for surjective. So recall here, though, to show that a function is surjective, we want to show that all elements in the codomain have an element in the domain that gets mapped to it. So we said for all elements there exists another element. So everything in the codomain, there exists something in the domain that gets mapped to it. So this statement here, we're going to, again, start with the same functions. G and F are defined the same way. And now instead, F and G are both going to be assumed to be surjective, so that the composition of these two functions is also surjective. So we approach this using a similar thing. We look at this and we say, how can I use this? All right, so we're going to have our proof. So we need to take an element in the codomain of the composition of functions here. So we're going to say let F and G be surjective. Okay. Now I take an element from the codomain of the composition. Remember, this is the function we're looking at, is the composition. So remember, if we're thinking that it looks like this, we're taking G as the first function. So we're going to take something here, plug it into G, we get something into B. Then that goes into F. F takes that from B and spits out something from C. So the composition has the codomain being C in this case. So let, say, X be an element of C. So I pick any arbitrary element in my codomain of the composition of functions. Now we're trying to figure out, how can I find something all the way back to the original? The domain of F composed with G is an A. So I need to work myself back 2 steps. So here, if X is in C, well, that's the codomain of F, right? So if we can now figure out what's going on with B, that'll be great. So since F is surjective, there exists some, say, Y that's in B such that F of Y is equal to X. Great, so now we know that there is something in B that gets mapped to X. Now we're trying to work all the way back, so we're trying to get to A. But great news here is that obviously, since this is a well-defined composition, the codomain of G is the same as the domain of B. So now we can use that to help us get to the final step. So since G is surjective, and Y is an element of B, there exists some Z which is in our set A such that G of Z is equal to Y. So if we look at the codomain of G, we know this is surjective. Any element in there must have a buddy that's in the domain that gets mapped to it. Okay, so this is great. Now we just have to piece all this back together with the composition. So now notice that F composed with G of, which one we want to start with, Z is equal to F of G of Z. We said G of Z was the same thing as Y. This is going to be F of Y, which is equal to X. So therefore, any element in the codomain of F composed with G, this is the set C, right? So any element in the codomain of this has an element in the domain of F composed with G, which is in this case the set A, that gets mapped to it. And that concludes our proof that indeed we have that the composition is surjective, because we show that any element in the codomain of the composition has an element in the domain of the same function that gets mapped to it.